Hey, welcome to the Explainer. Today, we're going to step into the high-stakes world of a senior Azure architect interview. We're going to break down some of the toughest scenario-based questions to really show you how a top-tier expert actually thinks. So, picture this. You're in an interview, and they drop a bombshell of a question on you, a big one like this. Now, they're not really looking for you to just list off a bunch of Azure services, right? What they're really testing is your whole thought process. Can you take a huge, abstract challenge and build a logical, strategic framework around it right from scratch? That's the real test. And that's exactly what we're going to do here. We're going to walk through three pretty classic but tricky Azure scenarios. But look, we're not just hunting for the right answer from a textbook. The goal here is that by the end, you'll start to see the hidden patterns, the architectural DNA that connects all great cloud solutions. Okay, so first up, let's tackle that huge migration question. We're going to design a secure and scalable virtual network, basically the digital foundation for a company's entire move to the cloud. Okay, let's dive right in. So you're faced with this massive task. Where do you even begin, right? Well, a great architect doesn't just start clicking buttons and deploying stuff. Nope, they start with a plan. They break the problem down into a few core, manageable pillars. See, a really solid network design, it always comes down to these four pillars. We kick things off with topology. You can think of this like, like drawing up the blueprint for a building. You wouldn't put the public lobby right next to the super secure server room, would you? It's the same idea here. We use separate subnets to keep our web servers apart from our databases. That simple separation, it's a huge first step for both organization and, of course, security. All right, next up is connectivity. So how does our shiny new cloud setup talk back to the old on-premises data center? Securely, of course. Well, you've got two main choices. Think of the VPN gateway like a really secure armored truck that's driving on the public internet. It's solid, it gets the job done for most things. But for your absolute mission-critical data, the stuff that needs its own private, high-speed highway with zero traffic, that's when you bring out the big guns, Azure Express Route. It's a dedicated private link that basically guarantees speed and reliability. And finally, we wrap it all up by layering on security and scalability. The Azure Firewall, that's like the main security checkpoint for the whole network, checking the ID of everything coming in and going out. Then you've got network security groups, or NSGs. Think of these like the security guards posted outside individual rooms, controlling exactly who can talk to who inside the network. And to make sure we can handle growth, the load balancer acts like a traffic cop, making sure requests are spread out evenly so no single server gets totally swamped. Okay, let's move on to our next challenge, and you'll see how these ideas start to connect. Imagine you're running a big e-commerce site, and it's Black Friday. How in the world do you build it so it can handle a crazy sudden spike in traffic without someone having to manually spin up new servers in a panic? The absolute number one non-negotiable key to making automatic scaling work is this idea of a stateless application. So, what does that even mean? It just means that no single server is holding on to any one user's personal shopping cart or session info. It's kind of like a call center where any agent can pick up your call and instantly have your entire history in front of them. Because of that, we can throw 100 new servers at the problem during a rush and then get rid of them when things quiet down, all without the user ever noticing a thing. It's seamless. So, how do we manage this army of servers? Well, the magic ingredient here is something called a virtual machine scale set, or VMSS. This thing is amazing. It lets us treat a whole group of 100 or even 1,000 identical virtual machines as if they were just one single thing. You need to update all of them, patch them all, scale them all up or down. You just do it once, right through the VMSS. It's a huge time saver. And here is where it all comes together in this really elegant system. You've got the load balancer at the front door directing traffic. The VMSS is our flexible pool of servers ready to grow or shrink on demand, but the real brains of the operation, that's in the auto-scaling policies. We literally just tell it, hey, if the average CPU load across all the machines hits 75%, start adding new ones. And if it drops below 25%, start shutting them down to save us some money. It becomes this completely automated, self-healing, self-regulating system. Okay, on to our third and final scenario. Imagine a company has just mountains of data. We're talking petabytes of old log files, records, backups, stuff they have to keep for legal reasons for years, but they almost never need to look at it. How do they store all of that without going broke? The whole solution here is realizing that not all data is created equal, and this is where tiered storage in Azure is just brilliant. Azure gets that the data you're actively working on right now is way different from a backup you made 5 years ago. And as you can see here, you pay the most to store your hot data, but in return, it's instantly available. But as that data gets colder, meaning you access it less and less, the storage cost just plummets. Archive storage is dirt cheap, but there's always a trade-off, right? It could take several hours to get that data back.
Now, here's the best part. You don't need a poor intern sitting there manually moving files around to save money. Nope, you automate the whole thing using the lifecycle management policies. You set up these super simple rules just like you see here. Okay, if a file hasn't been opened in 30 days, go ahead and move it to the cool tier. After 180 days with no activity, just push it all the way down to archive. It's a total set it and forget it strategy that's always working in the background to optimize your costs.
Okay, so let's just take a step back for a second. We've tackled a network design, an application that scales, and a data storage strategy. Now, on the surface, those seem like totally different problems, right? But if you look at how we solved them, you'll see they all share this same underlying philosophy. And that is the core mindset of a great cloud architect. These are pretty much the guiding stars. First, security is never an add-on. It's baked in from the very beginning with things like NSGs. Second, automate everything you possibly can, from scaling your servers to moving your data. It just makes things more reliable and efficient. Third, plan for things to break. It sounds pessimistic, but it's not. You build resilient systems with redundancy so that when something does fail, nobody even notices. And finally, always optimize for cost. You actively manage your resources using the right tools for the job, just like we did with those storage tiers and the auto-scaling rules. And really, that brings us to the most important point of all. Getting good at the cloud isn't about memorizing a giant list of services. I mean, that list changes every month anyway. It's about getting these core principles so deep into your thinking that you can apply them to any new problem that comes your way. The tools will change, for sure, but this strategic way of thinking, that's what really defines a great architect and lets you solve the problems of tomorrow.